Hi friends, in the last video we have learned the concept of matrices. What do you mean by a matrix? Yes, let us just recall the definition of a matrix. A matrix is an ordered rectangular array of numbers. And we have also learned the order of a matrix. Okay, so in this video we are going to discuss the different types of matrices. Let us consider one matrix. Consider this matrix. Tell me, what is the order of this matrix? Yes, to say the order, we know how many rows are there and how many columns are there. In this matrix, how many rows are there? Yes, there are 4 rows. Okay, then how many columns are there? Just one column. So, the order of this matrix is 4 by 1. 4 by 1. Let us consider one more example. What about this matrix? What is the order of this matrix? Yes, there are 3 rows and only 1 column. So the order of this matrix is 3 by 1, or this is a 3 by 1 ordered matrix. So this type of matrix are called a column matrix, since these matrices have only one column. So they are called a column matrix. Okay, a matrix is said to be a column matrix if it has only one column. Keep in your mind, a matrix is said to be a column matrix if it has only one column. Here, this matrix having only one column. This matrix having only one column. So these types of matrices are known as column matrices. In general, A is equal to the matrix Aij of order m by 1 is called a column matrix of order m by 1. This m indicates there are m rows but only one column. Okay, so these types of matrices are known as a column matrix. Now let us consider another example. Consider this matrix. What is the order of this matrix? Yes, how many rows are there? 1. Only one row. How many columns are there? 1, 2, 3, 4. There are 4 columns. So the order of this matrix is 1 by 4. Yes, okay. Let us consider one more example. X minus 2, 2. What is the order of this matrix? Yes, this is a 1 by 2 order matrix. So from these two examples, let us see that there are only one row. For both these matrices, only one row is there. Okay. So these types of matrices are known as row matrices. Okay, these types of matrices are known as row matrices. That is, a matrix is said to be row matrix if it has only one row. From the name itself, let us assume the definition of the matrix. That is, row matrix means it has only one row. That is, in general, a matrix B is equal to Bij of order 1 by n of order 1 by n is called a row matrix. Here number of row is 1, columns n columns are there. So this notation we use to denote a row matrix. Okay. Now let us see another type of matrix. Okay, consider these examples. Consider this matrix. What is the order of this matrix? Yes, it is very clear. This is an 2 by 2 matrix. A 2 by 2 matrix. Now let us see another example. What is the order of this matrix? 3 rows are there, 3 columns are there. So this is a 3 by 3 order matrix. Okay. From these both matrices, let us see that the number of rows and the number of columns are here equal. In both matrices, here the number of columns and number of rows are equal. Here, how many rows are there? 3 rows and 3 columns are there. So the number of rows and number of columns are equal in both matrices. So this type of matrices, that is, if a matrix having equal number of columns and rows, then such type of matrices are known as a square matrix. Okay, that is a matrix in which the number of rows are equal to the number of columns is called a square matrix. That is, an m by n matrix is said to be a square matrix if m is equal to n. Okay, let us just generalize this. That is, if A is equal to Aij of order m by m is called a square matrix of order m by m. Since here the number of rows and the number of columns are equal, let us say that this matrix is a square matrix of order 3. No need to say 3 by 3 matrix. Since the number of columns and number of rows are equal, while we say the order of the matrix, we just say this is a square matrix of order 3. Like that, this, let us say this is a square matrix of order 2. This is a square matrix of order m. Now, in a square matrix, here these elements, okay, in a square matrix, these elements constitute its diagonal. That is, here minus x is the element or entry in the first row and the first column. That is, this is what A11. Now this is the second row, the element in the second row and second column. So this is A22. Next, this is A33. Okay, so these elements A11, A22, A33, etc. These elements or entries constitute the diagonal of this matrix. Here 2 minus 3. Here A11 is 2, and this is A22 minus 3. So this 2 and minus 3 known as its diagonal. That is, if Aij is a square matrix of order n, then the elements A11, A22, A33, etc., ANN are said to constitute the diagonal of the matrix Aij or the matrix A. If this matrix is denoted by A, then these elements A11, A22, etc. A and n are said to be the diagonal of the matrix A. Okay. Okay, now let us consider two examples. Two matrices B is equal to -1, 0, 0, 2. Another one C is equal to -1.1, 0, 0, 0, 2, 0, 0, 0, 3. Here, what speciality can you see in these two matrices? എന്ത് പ്രത്യേകതയാണ് ഈ രണ്ട് മെട്രിസസിൽ നിങ്ങൾ കാണുന്നത്? Yes, tell me. Yes, first one, let us see that this is a square matrix. Since the number of rows and the number of columns are equal, this is a square matrix. Similarly, this also, that is, both these matrices are square matrices. Here the order of the matrix is 3 and here it is 2. So this is one speciality or peculiarity of this two matrices. Then can you see anything else? Yes, in this both matrices, let us see that their non-diagonal elements are zeros. All the non-diagonal elements here, these -1, 2 are known as the diagonal elements, or this -1, 2 constitute the diagonal of this matrix B. Here the rest are zeros. What about here? All the non-diagonal elements are 0. So this type of matrices are called a diagonal matrix. So a diagonal matrix must be a square matrix. Okay, then there all non-zero elements are zeros. Okay, that is a square matrix B is equal to Bij is said to be a diagonal matrix if all its non-zero elements are 0. Okay, that is a matrix B is equal to Bij of order m by m is said to be a diagonal matrix if Bij is equal to 0 for all I not equal to j. Okay, for all I not equal to j, this element will be a 0. So that type of matrices are known as a diagonal matrix. Okay, now let us see another example. Okay, let us consider this example. The matrix D is equal to root 2, 0, 0, 0, root 2, 0, 0, 0, root 2. Again, let us see that this is a square matrix. Since the number of rows and number of columns are equal, it is clearly a square matrix. Then from the earlier definition, let us say that this is a diagonal matrix. Since its all non-diagonal elements are 0, so this is a diagonal matrix. Yes, okay. Then apart from these two, can you see any other speciality for this matrix D? Yes, here let us see that diagonal elements, all the diagonal elements are equal or a constant, root 2. Yes, okay, here the diagonal elements varies. Here it is -1.1, here it is 2, here it is 3. But in the matrix D, all these diagonal elements are equal. So these type of matrix are called scalar matrix. So a diagonal matrix is said to be scalar matrix if all of its diagonal elements are equal. That is, a square matrix A is equal to Aij of order m by m is said to be a scalar matrix if if Aij is equal to 0 for all I not equal to j, and if Aij is equal to k, a constant for I is equal to j. Okay, that is a square matrix Aij of order m is said to be a scalar matrix. This is the condition if Aij is equal to 0 for all I not equal to j, that is for all non-diagonal elements the values is 0, and if Aij is equal to k, that is all diagonal elements equal to a constant. Okay, this is the condition for a square matrix to be a scalar matrix. Yes, now let us move to another example. Now let us consider another three matrices. First one, here matrix 1. What about this matrix? This is a matrix of order 1. There is only one element and it is a matrix of order 1. Next, 1 0 0 1. This is a 2 by 2 matrix. Third one is a 3 by 3 matrix. Now let us see that all these three matrices are square matrices, examples for square matrices, since their number of rows are equal to number of columns. Then not only they are square matrices, let us see that their non-diagonal elements are all zeros, so they are diagonal. They are diagonal matrix. Now what about their diagonal elements? All here diagonal elements 1 1, here 1 1 1 are equal. Since the diagonal elements are equal, such a matrix are called as scalar matrices. So these three are scalar examples for scalar matrices. Now see, in the case of scalar matrices, we have seen that their diagonal elements may be 1 1 1 or 2 2 2, 3 3 3, etc. No need to be it only 1 1 1. But here all the three matrices, their diagonal elements are equal to 1. So these types, that is if the diagonal elements of a scalar matrix are equal to 1, then it is called a identity matrix. It is called an identity matrix. So a square matrix in which the elements in the diagonal are all 1 and the rest are all zeros, it is called a identity matrix. We denote an identity matrix by the symbol in, and here this n indicates the order of the matrix. We have already discussed the order of a square matrix is denoted by only one number. A 3 by 3 matrix is denoted by 3 only, of order 3. We used to say order 3. We used to say a 4 by 4 matrix as a matrix of order 4. Similarly, an n by n matrix is used to say a matrix of order n. So one n we use there. Now to denote an identity matrix of order n is denoted by n, is denoted by in. But the order of an identity matrix is clear from the context. Let us denote an identity matrix by only I. Okay, why? Because that is the order of an identity matrix the order of an identity matrix is clear from the context. So no need to use some in or something else. Only I. This is enough to denote a identity matrix. Okay. Now let us see another type of matrix. That is, consider this example 0, 0, 0, or another matrix. Here all, consider this example, the matrix 0, 0, 0, 0, or this matrix or this matrix. Here all the elements of these matrices are zeros. So these types of matrices, that is, in a matrix, if all the elements are 0, then they are called a zero matrix or null matrix. They are called a zero matrix or null matrix. So a zero matrix or null matrix means a matrix in which all the elements are 0 is called a null matrix or zero matrix. That is, a matrix is said to be zero or null matrix if all its elements are 0. Now, a zero matrix is denoted by the letter O. Denoted by O. Again, the order of a zero matrix is clear from the context. So, there is no need to mention order of a zero matrix. Okay. Now, let us consider two matrices. A is equal to the matrix 2, 4, minus 8, 10. Another matrix B is equal to 2, 4, minus 8, 10. Now, what about these two matrices A and B? Yes, let us see that these two matrices A and B have the same order. What is the order of this matrix? The order of this matrix is 2. Okay, this is a 2 by 2 order matrix. Here this also 2. The order of this matrix is also 2. That is, both of these matrices have the same order. A and B are of the same order matrix, that is 2 by 2 order matrix. Now, what about the elements of these two matrices? Here, let us see that each element of the matrix A is equal to the corresponding elements of the matrix B. Here, first A11 is here 2. In this matrix B also, the A11 is 2. Then A12 is here 4. That of B is also 4. A21 is minus 8. Here also A21 is minus 8. Then A22 is 10. Again here it is 10. So each element of the matrix A is equal to the corresponding element of the matrix B. So these types of matrices are known as equal matrices or the equality of two matrices. Okay, so two matrices A is equal to Aij and B is equal to Bij are said to be equal if A and B are of the same order. Okay, both matrices A and B have the same order. Second one, each element of A is equal to the corresponding element of B. That is, Aij is equal to Bij for all I and J. So this is the two conditions for the equality of two matrices. First one, both of them should have the same order. Second one, each element of the first matrix will be equal to the corresponding element of the second matrix. Okay, then let us say those two matrices are equal matrices. So let us wind up our today's video here. Before that, let us just recall what are the things we have discussed in our today's video. We discussed different types of matrices. What are the different types of matrices? First one is column matrix. What is a column matrix? A column matrix, a matrix having only one column is known as a column matrix. Then second we have discussed row matrix. A matrix having only one row is known as what? A row matrix. Then next we discussed a square matrix. What is a square matrix? That is the number of rows of a matrix is equal to number of columns, then it is known as a square matrix. Then next we discussed a diagonal matrix. Diagonal matrix is a square matrix, but their non-diagonal elements are all 0. If all the diagonal elements are equal, then it is called a scalar matrix. Now, in a scalar matrix, the diagonal elements are equal to 1. It is called as an identity matrix. ഇവിടെ നമ്മൾ പ്രത്യേകം ഓർക്കണം, ഒരു ഐഡന്റിറ്റി മെട്രിക്സ് എന്ന് പറഞ്ഞാൽ അതൊരു സ്കേലാർ മെട്രിക്സ് ആണ്, അതേപോലെ അതൊരു സ്ക്വയർ മെട്രിക്സ് ആണ്. എല്ലാ സ്കേലാർ മെട്രിക്സും എന്തല്ല? ഐഡന്റിറ്റി മെട്രിക്സ്. ദാറ്റ് യു ഹാവ് ടു കീപ്പ് ഇൻ യുവർ മൈൻഡ്. ഓക്കെ, എല്ലാ സ്കേലാർ മെട്രിക്സും ഐഡന്റിറ്റി മെട്രിക്സ് അല്ല. All scalar matrices are not identity matrix, but all identity matrices are scalar matrix. Then next we discuss the equality of two matrices. എന്താണ് two matricesന്റെ ഇക്വാലിറ്റിക്ക് വേണ്ടത്? there are two conditions. What are the two conditions? ഒന്ന്, രണ്ട് മെട്രിസസിന്റെയും ഓർഡർ ഈക്വൽ ആയിരിക്കണം. സെക്കൻഡ് വൺ, each element of one matrix will be equal to the corresponding element of the other matrix. ഇത്രയും കാര്യങ്ങളാണ് ഇന്നത്തെ നമ്മുടെ ക്ലാസ്സിൽ ഡിസ്കസ് ചെയ്തത്. ഇനി the problems related to this section will be discussed in the next video. So all of you try to watch that video also. Okay, thank you.